Hello and welcome to the National Grid DG Technical Submittals webinar. Today we're going to walk through the documentation that is required for the construction phase of DG projects. My name is Carrie Doyle and our presenters today are Jean Hickok, Tim Dimian, and Chris Vance. They'll be with you in just a minute. I just have a few housekeeping issues to go over first. We have already muted our phone lines, and the reason we do that is just to make sure that we have a really high-quality audio experience. We're also going to be recording the session, so we don't want any background noise to interfere with that recording. By Friday, you will be able to find this recording on YouTube by searching keywords National Grid Distributed Generation, and it will be up there at any time you need to reference it. Our presentation, at the end of our presentation, we will answer chat questions, so please type those into the chat. But we do ask you to hold off until the end of the presentation. A lot of times when we do get those questions ahead of time, they keep popping up on the screen. It just makes it really distracting for our presenters. Also, please at this time, if you wouldn't mind checking to make sure that your video cameras are off. There are some times that we do see a bunch of our participants on the cameras, and we just want to make sure that that's not a distraction either. At this time, I'll ask Tim to take over and go through the agenda for us.
Okay. Thank you, Carrie. As Carrie mentioned, my name is Tim Dimian. I'm a lead energy consultant here at National Grid, and helping me today is Chris Vance, a principal engineer for Retail Connections Policy and Standards. Today, first we will have a brief safety message. Then we'll go through the initial site visit, the design created and final project schedule, customer design and customer review, then on to company construction, field verification, witness test, and permission to operate. Additionally, I also have a slide with contacts, and at the end, we will have a question and answer period. With that, I'll turn it over to Jean for our safety message. Take it away, Jean.
Hello, everyone. At National Grid, if you haven't been with us in the past, every meeting we have a safety message that starts the meeting. And interestingly enough, I've even carried that over into my personal life. So this safety message is going to be on summer safety moments, safety tips. And the brief outline here comes from the National Safety Council. So the first thing I have is beat the heat. Anybody can be at risk for heat-related illness, and and basically take breaks, drink lots of water. Electrolytes help, and if you have lost a lot of fluids, you might want to consider salt, but always consult the doctor. Some of the symptoms are chills or not feeling thirsty any longer. So bug safety is big here in the Northeast with ticks. We were just issued tick kits for ourselves, and we're wandering out, but it's a big issue for our linemen and field personnel. So have bug spray and be properly dressed when traveling, hiking, and know what bugs are in the area too, because sometimes they migrate and you may not be aware. Playgrounds, that was shocking to me. I have a friend that's an emergency room tech, and they call the summer silly season, but 20,000 kids ages 14 and younger have traumatic brain injuries each year from playgrounds. So something to consider. Fireworks, always dangerous, and if they are legal, make sure there's adult supervision, but be careful, better to be viewed than to play with. So Tim, next slide. Bicycling, I've done more than my share of falls, and that was before helmets. But always wear proper protection, and keep in mind if you're riding on a road, distractions from texting and other distractions from drivers. I pretty much stopped riding on the roads and go just to bike trails and mountain biking. So, but keep in mind the distraction, rear view mirrors, belt, and just keep a constant vigil. Water safety, I can't stress that enough. We've already had a fatality up here in Lake George. So life jackets, even if you're a good swimmer, wear a life jacket. If you hit your head, fall in, get a cramp, and then young children, make sure they're supervised. Skateboarding, which wasn't very popular, but again, something that requires helmets and knee pads and knee protection. And again, don't let someone go off and skateboard alone. Boating, there's always accidents and slips and spills. The big one, we had a couple people here at work putting the boats in on the concrete boat launches. They're slippery, and you slip and you may not even fall, but you could twist your back or hurt yourself. And pedestrian safety, put the cell phone away and look up when you're near cars or out in traffic. Keep a vigil again, because if you're texting it on your cell phone and the driver's texting it on their cell phone, I had one last summer where a woman was jogging and looking at her cell phone and almost ran out in front of me. So that's my safety message. Enjoy the summer, but be safe. Thanks.
All right, thanks, Gene. Very timely with school about to end and summer vacations coming up and the partaking of all these extracurricular activities. Very timely. Thank you. So before we get into the initial site visit, let's just go back and remember how we got to this point. The interconnection customer filed an application, paid a $750 application fee. Then the application was reviewed by National Grid screening team. A preliminary study was done, and then the interconnection customer decided to move on with the full study, also known as the Caesar. Paid the study fee, provided any additional documentation noted in the preliminary Caesar, and the Caesar was completed. Reviewed with the customer, and then he decided to move forward and paid his either 25% or 100% so he can move on to construction. The unfortunate part is making that 25% or 100% payment doesn't really move you forward at that point in time. In order to get to the next phase, which is the initial site visit, we also need some additional documentation, and there has to be some activity out in the field. We need a revised site plan showing where the customer pole locations are going to be, along with the property lines and the access road. The site needs to be staked out in the field, so when we get out there with you, we can see visibly where everything is going to be. And then if there were any changes to the application, such as a generator size change or anything like that, we'll need an updated Appendix B, single line diagram, and 3-line diagram. Now to kind of just step you through all those site applications, this would be typical for a typical site application for when the customer had made his application. Very basic, shows the array, some streets, some basic information, the potential point of common coupling, and where the customer's equipment is going to be. It's also important to note that within the title block, we should be putting the customer's name, and that's the name that is actually on our CSS billing account, and also the site address. So in case this document does get lost over here, we can easily figure out where it belongs. Moving on, when we get to the initial site visit, like I said, through the Caesar, we'll ask for a revised site plan, and it will look something like this. Something a little bit more detailed, a little bit better picture of the array. You'll see an access road along here, customer's proposed pole line, some notes on the pole line, what each pole is, utility-owned pole, customer-owned pole, what is disconnect switch, utility pole for the meter, so on and so forth. We'll also see property lines and fence lines. And this is good enough for us to get out in the field and take a look. And again, you'll have all this information staked out in the field, so when we get out there, we'll be able to see how all this lines up. Then once the site visit is done, you can go back and revise the site plan into its final format. And as you can see with this one, there were some revisions made. This pole line now is on the right side of their driveway. If you recall in the previous one, it started out on the right side and then moved to the left side. And then again, we got the notes on the pole lines, the property lines, the fences, and so on and so forth. And we have clearly marked the point of common coupling we're going to connect to. Like I said before, it's important to stake the locations out in the field And I purposely chose this picture because it's very difficult to see the stakes, but most of the time when we go out in the field, you think of it as being just an empty farmer's field. So when the customer places the stakes out there, they're very easy to see. It's also very easy to see where the property lines are. In this case, you can't see that. There's a lot of vegetation. So we asked that everything be staked out in the field, and you can see that all the stakes here lined up. I've got them circled in case you can't see them. And we also see the stake for the property line. So we can make some visual inspections and see how all this is going to lay out. Now, additionally, once you get the Caesar, there's some comments within that Caesar, and it will ask you to make some revisions to it. I've highlighted some of those comments, and this is found in section 6 of the Caesar. And as you can see under point 2, the interconnection customer shall build the access road. We mentioned that before, it has to be there. An updated site plan is required to show the proposed customer pole locations. The interconnection customer shall update the 3-line diagram. So these are the types of notes you should be looking for to make any types of updates, not only for the initial site visit, but for further revisions down the road when we get into more detailed plans that are required. I forgot to mention that this is the existing format that you'll see where the comments are. And again, this is in section 6 of the Caesar. And you can see how it's all listed out in bullet points. We've been going through some revisions of the Caesar, and it's going to be condensed. So this is what the new version is going to look like. It's going to be in an Excel spreadsheet. It's really going to detail a lot of different things. It's going to reference the drawings, any document numbers on those drawings, the date the comments were made, and any comments or questions that the engineer has.
So to speak for just a second on that, so with the existing example, a lot of the information that we provide back specifically to drawings, modifications, and such is in paragraph form with some free-form text that someone typed up and some bulletized items. And that would be processed at the study phase. And moving forward with the overhaul of the CSER final study template that the joint utilities are working on, we're pulling out those specific comments that pertain to mostly the constructability or physical requirements of the drawing package submitted, and we're including them in this Excel format that's more like an action items type list that National Grid has typically provided post-study on most of our projects anyway. So we're pulling forward that vehicle that we're using post-study into the final study phase to better align with the comment flow and it really to provide better usability to the end user and clarity as to what we're asking for to try to smooth and streamline the process.
All right, thanks, Chris. So now that the site visit is completed, any updates made and approved, we can move on to the design stage, which will then lead into the final schedule. National Grid will develop that final schedule once we receive what's called a pole arrangement drawing, and I have an example of this on the next slide. And that is included, you can see a reference to that in ESP 753 for any guidance on that. Also, if there were any changes made to the pole locations out in the field, they have to be restaked so our design team can make an accurate design on our part. And then also the revised site plan. If you remember that last site plan I showed you, showed all the revisions on there, we're going to need that as well. So here's an example of the pole arrangement diagram. It should include dimensions between conductors, equipment, include any references to manufacturers and equipment type and things of that nature. And Chris, I'll let you go into a little bit more detail on this.
Yep, so this example is a pretty solid example of what would be good information to provide for pole arrangements if you're providing an overhead primary service. or if we're providing that to you. So in this illustration, some of the key components are, first off, we have a large side view on the left-hand side of the page where we show the pole from a side perspective, and that angle gives us a lot of good information as to what exactly is on this pole. Along with the information from that side angle, it gives us the pole heights as well as some equipment from that perspective and the parts and pieces that we'd be looking for. That angle alone gives us a lot of information, but doesn't quite get us all the way. So another good view of that drawing is right there in the left-hand corner. It's shown in this case as a section A-8AA, and that gives us a top view of that pole. So giving a top view of that pole, I'm sorry, that's an exploded side view. Now that's an exploded side view from a different angle, and that angle gives us more information that you cannot quite see from that side profile of the pole. That gives us further detail as to the equipment arrangements on the crossarms, when the spatial relationships associated with that equipment as well. And then we move over on the page, and there's another section, DV, that does give the top view. Now that top view is also important because, again, it gives us the spatial relationships. So between the side view from the one angle, and we turn and take a side view from another angle, and then the top view, we now can visually, as we review these drawings, get a better representation of how that three-dimensional object is being represented on this two-dimensional plan. Now, the one item that is shown on here, which does lend for usability for the reviewer, is the isometric plan, or the view, the isometric view, which is the one that looks as the pole is at an angle. Now, that does provide usability, and it does make the engineer's reviewing job easier, but that is not a requirement, although it does improve, like I said, the ease of reviewability when we do have those ISOs. So if they were included, that would be great. If they are not included, it's not a mandate for the ISO, but it's nice to have. The other ones, if you have equipment such as this pole arrangement, would be essential components to having a proper pole arrangement drawing. And then in the bottom right-hand corner, it shows the underground work for the equal potential grid required and the grounding to give a full picture of what is going into that specific pole build. Also, typically, with a pole drawing such as this, it would reference back to the overall site plan. So from the site plan is where you can initiate your sections or your views in respect to what this pole arrangement looks like. And then we can tie those two drawings together through all the detail provided here at the pole drawing, tie that back to the site plan, so we would know exactly where this pole lies, what equipment is going on the physical makeup of the pole, and based off of the tie back to the plan view, we should be able to tell what direction this pole is intended on traveling.
Okay, great. Thanks, Chris. So again, that's just one piece of what's required to start the utility design and get to the final schedule. A little bit more detail than what was required for the initial site plan, but it starts to get us there and starts to give us an idea of what everything is going to look like. The other pieces, again, the stakes out in the field, if they have to be moved, they should be moved as soon as possible. And then, again, the final site plan, which was mostly put together after the initial site visit. So this one should be pretty much done. Now, the final schedule, hopefully most of you have seen this. This is really a final schedule that's put together but the unfortunate part is not all-inclusive, and it's meant not to be that way. If you're looking for an all-inclusive list of things to do or milestone schedules, you really need to rely on your individual construction schedule or construction calls that you have between the company and yourselves. But this will give you an idea of some of the milestones that have to be met in order for us to meet the estimated connect date, or what we call the ready for load date. And here we show that as 6/1. And just to give you some examples, in here we had to put down the field visit, had to be done on September 20th of 2017. The recloser settings had to be done between January 25th and February 15th. Permitting, there's no permitting associated with this, but there are easements. So the easements were sent out on or around January 15th. We need to get those back by March 16th. Some other things, picking up of the metering equipment needs to be done by March 19th. So all these dates will give you an idea of what has to occur and when it has to occur by in order to meet this June 1st estimated connect date. And if any of these dates slip, that endangers this date here, the June 1st date, and may push that out. So a very important document to discuss on all your construction calls. Now, to start the customer design and construction review, this is where we really get into all the detailed drawings. And I'm going to really let Chris walk through all this. And we'll start out with the stamped site plan, again, which was mostly developed based on our site visit. But then we'll get into the stamped single line, 3 lines, the AC/DC elementaries if they're required, PE stamped electrical assembly diagrams, relay settings, perfected device coordination, the labeling of equipment on drawings, and detailed cut sheets. So Chris, if you want to take it away with the site plan, and then we'll move on.
Absolutely. So with a site plan, as you've seen some of the examples before, and we understand as well, they can be an iterative process. But as we progress through and discuss the changes needed or the modifications needed to satisfy the project, ultimately we need to arrive at what would be considered for a project that is over 600 volts to be a PE stamped site plan. So the engineer of record is going to stamp and seal this one. That authenticates that design as the design intended to move into construction, and then we have everything that would be basically kind of soft cast into concrete, understanding there are slight as-built from time to time, what would be expected at the project. So on this example, it shows a lot of the key components that we would be very much interested in. One of which is obviously being the site location. And a key part of that site location, which hopefully carried from the beginning, would be something like a north arrow. Like in this project, there's a north arrow or a compass shown in the upper corner. And on this project, it would indicate to me that north was directly page north or top of page. And then another good component is a scale. So, and I like to talk to these items first because those are very critical to make sure we understand the orientation of the project and the scale relative to the drawing in case we have any questions on physical arrangements or clearances or rights of way that, space requirements that we would need or be keen or concerned with. And then, of course, we show the PV array and the all that equipment shown out graphically, and that's good. Then we would be interested in the path of connection from our location where we would have discussed the pole location or the tapping point of our line. And we see on this drawing it shows the different pole arrangements as they travel down the access road with dimensions on distances between the poles. So we can get a good understanding and agreement on how far everything is spatially separated as it travels down to make sure the engineering that goes into this drawing is going to be constructible. And then another good key component is the actual access road. Now that access road is key because if we have to get back there to inspect equipment, if to have access to the site at minimum to the overhead service point is a requirement. So to have that access road illustrated is good construction or good engineering practice because it will be required. And we need to be able to have that shown and make sure it's out there built satisfactorily so we can access equipment that we would that National Grid as a company would be interested in inspecting, or if it's equipment that we may have to own or operate from that facility. Also, as Tim mentioned before, having, by now we would have clearly identified the boundaries of the property and then any conditions or nuances associated with that. And if there's any fencing or site restrictions or access gates, we would want that illustrated. And if there is an access gate to the front of the property and the site was, per se, in the back of the property, that front access gate we would want to have shown with dual locking provisions to make sure that if we have to have access back to our equipment, that we can gain access 24/7. So if we can move to the next drawing.
Okay, single line?
Yep, yes, please.
No comment on the single line, Chris?
I do. The slide is not advanced on the...
Oh, it's advanced on mine. Let me go back and try it again. Can you see it now?
Still hasn't advanced, Tim.
Tim, it advanced on my slide.
Yeah, it's advancing.
Okay, well, there we go. Now we got it. Must have been maybe a delay in the internet. So, all right, so single line. Single line drawing is very important to everyone involved in the design, as it is the electrical representation of the equipment arrangement. So the single line provides us with a lot of valuable detail. It's going to show us the electrical path for all the equipment so we can make sure that everything lines up as expected. Again, this is a drawing that would need to be stamped because at this point in the process, we are finalized the design, right? We want to move towards the construction phase. So the key components that are very much of interest here are going to be the point of interconnection. So on this drawing, it shows a dashed line. Typically, with a system like the one shown with an overhead system, that demarcation is going to be at the fastening point to the three-phase gang-operated switch provided by the customer. So that's what's shown in this case. Showing that customer switch is important. And then if it's a gang-operated switch with a fused service arrangement like this one, we'd expect to see that. Or if it was an overhead type arrangement with a recloser, or whatever the overhead service protection would be, it would be that would be a requirement to show. And as we travel down the single line here, we are showing the utility metering. That is also required. It is something you would need to show. Now on this specific drawing, they are showing customer metering. That would not be necessary for us to see, but if it's part of your design and you want to have one package for submission to us, and it's the same package to submit to construction, and you want that installed with the construction contract, that's totally fine that you show it. But it is not required for National Grid to see the utility, or my apologies, to see the customer metering that's shown on this illustration. And then we move forward, and any associated disconnect that will be in line in the system that would be utilized for a disconnect function or needed as part of the scheme to operate, we would want to illustrate. And for in this case, we're showing some pad-mounted transformation. So that would be important. Along with the transformer, we would expect to see the sizing of the unit, the voltage ratings, the turns ratio or the step-down voltage value, if impedance value is needed. All this information would be expected to be shown on the transformer. The configuration of the transformer, if it's delta Y, YY, Y grounded, whatever that configuration is. In this case, this transformer has we have a neutral ground, I believe is what's shown on there. It's a little small. But if we have equipment such as if you're utilizing resistance or reactance in the ground, we would need to see that illustrated as well as the details of that shown on the drawing as well. So we'd understand the impedance value of that device and its current values or ratings, and any withstands or short circuit values that it possesses would be information we would like to see on the drawings. Then, of course, as you progress through, you would show your inverter make and models on the drawings as well as any appropriate sizes. When it comes to conductor lengths and conductors, they would be identified throughout the drawing as to the make and ampacity or rating of the conductor. Most simplistic fashion of showing that would be to list if the conductors, for instance, if it was an overhead, if you're using a 336 type ACSR or an all aluminum or whatever the conductor type would be, if you would list out the conductor type on the drawing. And lengths would not necessarily be needed on a single line if they were covered on the plan view or some schedule, but lengths could also sometimes provide assistance to us. And then as you make your way down through your equipment, any equipment that is of interest to the utilities, like the combiner panels or anything that would require a shunt tripping or some kind of overcurrent protective interface, we would have interest in, down to the system. Now, I would say with an existing system, so this shows a new system, if we had an existing system, We would also be very much interested in any of the existing infrastructure that was tied into the system. So if you had to reconfigure something to add the existing system, we would want to be knowledgeable as to how that interfaces as well, especially when it comes to service modifications.
Okay,
so
next, Doug.
I'm sorry, Tim? Next slide? Yes, thank you.
Yep.
So now the single line is very important. And so somebody may ask the question, well, why would I need a single line and a three-line diagram? And that would be a fair question. Three-line diagrams provide more detail than the single-line diagram can offer, especially when it comes to three-phase arrangements. Now, the single-line diagram and the three-phase arrangement would give us the distinct, it would distinctly identify transformer configurations, even though it may be stated on a single line. Showing it on a three-line would really clearly depict the wiring configuration, especially when it comes to instrumentation transformers that have to be either Y-grounded connected or some other fashion, maybe a broken delta. When the transformer is connected, you can see that this transformer has it's a Y impedance grounded with two delta secondary linings. So that kind of information really, with the three-line diagram, it clearly depicts that. And that information would not be necessarily discernible from a single line, to where if there's an error or some kind of omission made, we may not pick up on it, or it may be missed or misconstructed. So if you identify in a single line diagram that you have three of some element, and then come to find out later only one was installed in the field, and the only difference was maybe the three or the notation was overlooked or omitted, that can make a big difference in whether the project is a smooth constructed project or if there's something we have to go back and have retrofitted or modified later in the future, which of course would elongate the time it would take from the process starting to the process energization.
Okay, next slide, Doug.
Yes. Yep. Next slide. Okay. The AC and DC elementaries. So the elementary drawings are, well, sometimes they may not be required. If you have a fused service, there's not an elementary drawing to be had. But if you had a device that had an interface with, if you interface with some kind of a logic scheme, a protective logic scheme that may be embedded within a controls package or a standalone relay that integrates with something like a recloser or a breaker, if that scheme is necessary for the operation of the generation or the DER, we would want to see that. And again, that would also have to be a PE stamped drawing. So on this one, it shows basically kind of a ladder logic diagram where it shows all the inputs and outputs of the functionality of a specific relay. And that gives us a clear picture of how this relay is going to operate, what functions are being driven. We can trace the functions to different trip parameters or conditions or sequence of events that we would require. And it also shows the test switches associated with it, which would be very, I would want to say necessary, very fundamental to providing a proper witness test plan. Having the test switches to be able to isolate units so we can test them and test their functionality in the field, if there's troubleshooting needed on the device. So all that information gets displayed on a proper AC or DC elementary. Now, one other thing I'd like to point out on this drawing, and it also applies to all the drawings that we've been talking about, is symbology. It's very important to have a proper symbology. So if you have, for instance, a test switch, which is shown here, it looks like a standard switch operation. A test switch versus a standard test switch utilized for voltage, or something that would be a test switch for a current transformer, would be shown differently on the drawing, and it will also be installed differently on the field. A voltage test switch would be simply a test switch that opens. A current test switch would be something that you would not only need to open and isolate for testing, but anytime you open a current transformer, for instance, under when it has connected to a primary conductor and it can still be induced current flow on the CT, it would be very important to be able to shunt that test connection. So there are certain test switches for a current transformer, for example, that would need to be shun it across the terminals so it doesn't overexcite and cause catastrophic failure of that instrument. So the symbology of the test equipment itself, for that specific switch, as well as you can transfer that to any device using standard symbology, is very important. So as we have these types of drawings submitted, following standard symbology such as the symbology we provided in the back of the ESP 756B or any of our other ESP series, or any IEEE or industry standard accepted symbology, would aid, again, in the user's reviewability to make sure everyone understands the full scope and intent of the project. So we can go to the next slide. Yep, thank you. So electrical assembly. So we talked, I guess I already covered this a little bit previously. Again, this gets back to the physical arrangements. So this drawing, again, shows and highlights a lot of the physical arrangements that we've spoke about with the different section views to really paint a clear picture of the three-dimensional object on a two-dimensional space, right? When we receive paper product, a two-dimensional drawing, in order for us to visualize it, we have to see things at different angles to make sure all the spatial arrangements are going to work in respect to our requirements and make sure all the equipment is there per our requirements as well. And so, again, for instance, this one has the elevation view, and we have a top view, and then there are two different side view or section views, which properly give us enough information to where it would be a satisfactory submission so we can approve it and move on to construction.
I advanced it to relay settings, Chris. I don't know if you can see that.
So relay settings. So as part of the submission package, in order for us to advance towards towards witness testing, we would need, at that point in time, any relay settings that you would have for your equipment. So with this one, it's a specific ground time over current relay setting, but this is just an illustrative picture to show in respect to all relay settings. So if you have ground over current settings, or if you have other fault settings required because you are using a recloser or some kind of a three-phase automated device, such as a circuit breaker or some other type of automated device, we would have to review your settings to make sure they coordinate with our system. And that's a requirement before we could advance to witness testing, to make sure the settings are agreeable up front and we can make any tweaks before equipment gets installed in the field in case there has to be some modification or change. And this would only apply to, well, this specific type of setting would only apply to those type of three-phase automated devices. You would also submit if you had a fuse service. If you were anticipating utilizing a certain fuse type, we would expect to have that fuse type listed on the drawings, as well as getting the fuse characteristic curves so we can review those in coordination with our system as well. And in addition to those types of curves and settings files, we also require on paper for you to submit your inverter settings as well. And we would review those at that time to ensure that the inverter settings are in compliance with our ESPs and the IEEE required settings.
Okay.
So labeled equipment designators. So having equipment labels lends to, again, usability, and also it's very important to get these labels accurate and descriptive for future use as well. So having the labels on the drawings to indicate like which customer pole is which in series. So if we have poles customer 1, pole customer 2, pole customer 3, not only labeling that on the drawing is beneficial, but when we go into the field, actually getting those poles labeled in the field provide the ability to make sure everyone has a full, clear understanding as to which point or which device or what piece of equipment is being witness tested or operated. And that communication between our control centers and the local field operator, whether it's a utility personnel or a customer personnel, everyone can speak the same language and understand exactly what the other intends on doing. So having those equipment labels as designations is very critical to the success and sustainability of a site or operations. So having the equipment such as your recloser, if you have one labeled, fuses labeled, the gang-operated disconnect switch would get a specific label, and typically each pole would get a label. And again, those labels would be able to be traced back to an operator diagram and utilized for switching or communication purposes well into the future that extends past just the initial construction period.
Okay.
So along with the drawings and the relay settings and the equipment labeling, we also require cut sheets. Now, the cut sheets provide us a lot of valuable information. So instead of having someone type us up what the parameters of a specific piece of equipment is, we just request cut sheets. So with the cut sheet packages, if you're using a gang-operated three-phase disconnect switch, if you're using hook-step type fuses where you have a fuse and fuse holder, or if you're using a recloser or a circuit breaker, some kind of a shunt trip, the transformer, reactors and resistors, all those pieces of equipment have cut sheets, and they all tell a story. They all have the parameters that we would be interested in order to evaluate the design. So having those cut sheets submitted in a package greatly support our review process, and if we can have those, if you provide them sooner in the process with your first design package, that's okay, as long as they don't change. And if anything does change, if you promptly submit the new detailed cut sheet for us to have on file and to review for approval, the faster we get those cut sheets or the sooner we get them in hand as a full package, the faster we can advance to the next stage. And again, those cut sheets are important so we can validate the equipment, and when we review the equipment and then go out there and witness test or field verify, knowing that that equipment matches what we've agreed upon in the design phase, we would approve that, and we would have record of what the equipment is and understand how its functionality is expected to perform.
Okay. All right. Thanks, Chris. And as you can see, we're now into that stage where a lot more details are required. But, you know, Chris went over this in a very short period of time. You can refer to our ESB bulletins, in particular the ESB 751 carries information on everything Chris just went over. I brought up just this one section that kind of goes over the cut sheets, so it gives you a list of the cut sheets that are there. But you can always refer back to that, and always touch base with your National Grid engineer and your local CEI project manager if you got any questions, and we'll help you through it. And also with that action items list, you'll see what needs to be done, what's still missing, if anything needs to be changed or updated. So all very important things to remember as you're going through this stage. And typically this is the longest stage to go through because there are so many detailed drawings and you do need to meet a lot of different requirements. So just keep that in mind. There's a lot of information to refer to and also use National Grid as a resource. Now moving on to the next stage, the company equipment construction on the customer premise. Really what we need here is just an access road. It should be drivable and able to support one of our line trucks. This is just a view of a solar field where you can see the PCC recloser pole in the front and then the customer's disconnect pole behind that. Beyond that is the National Grid utility metering pole. So we actually have to get in about 3 poles into the property here. And you can see that this surface in the beginning is paved, and then it goes on to a stone road. This is perfect for us to gain access to our equipment. If we need to do any work, we can get in there and get at everything. And then for the field verification stage, we need to get into and see the stamped and accepted final construction package, really what Chris just went through, a PE certification letter, which is really just the engineer certifying that the installation's been installed per the approved design, and then also the inspection from the local authority having jurisdiction. From there, we can go on to the witness test, and obviously we got to get through the field verification first. That has to be done. But also you have to have approved test documents, the sequence of operations, the energization plan, the testing and commissioning plan, the maintenance plan. And again, you can refer to ESB 751 and also 756 for these. I did put the section from 751 in here so you can read the definitions of each one of those. Chris, I don't know if you want to go into any further discussion on the testing plans.
I just want to note that sometimes, so with more simplistic projects, sometimes the energization plan and testing plan would be one and the same because of the simple nature of the project. Those two terms separate as the projects get more complex. But for a simple installation like we were showing, a lot of times those plans are one and the same.
Okay, yeah, good point. And those will all be discussed during the construction calls that we have. We may tell you that one or the other may not be required, but if it is required, you know where to find them, give you a good start. And then once we get through the scheduling of the witness test, we go through it. Once it's successful, we'll give you permission to operate. And along with that, we'll get sign off on the actual test plans. We'll run through them during the witness test and then take down any as-left relay settings. Now, in case you're wondering where to find our electric system bulletins, I put the link up here to our website. This will bring you to the main page for our electrical specifications, and I circled the two sections where you can find those bulletins. I like to just go in and Google ESB 756 National Grid, and then you can find the link that will bring you to here. So as you can see, we've gone through quite a few steps in a very short period of time. We went through the initial site visit where it's really just more than a payment. You also need that site plan. You need the site staked. And if there's any revisions, such as the generator size, we need some additional documentation revised. Then when we went into the design and creating the final schedule, we got into a little bit more details with the pole arrangement drawing, the final locations of the poles staked out in the field, and then a revised site plan showing where everything's going to be, and it was agreed upon. And then when we get into the customer design and construction review, that's when you get into the real design package, the detailed design package that Chris went through. A lot of drawings in there, a lot of information required, data sheets, so on and so forth. And then the company construction. Again, we need that drivable surface, very important. Typically not a problem because by this time in the project schedule, the customers already started some site work, so the access road is there. Then we get into, again, the field verification where the engineer goes out, takes a look at everything, compares it to the construction drawings, make sure it all matches. Then we get into the witness test, final verification, go through all the test plans, the sequence of operations, so on and so forth. And from there, if everything is successful, we'll go to the permission to operate. So again, a lot covered in a short amount of time, but everything can be found within our bulletins and also discussed during our construction calls. As far as contacts are concerned, I listed all the contacts for the energy consultants that you may deal with. Our manager, Mike Palau, is shown in the upper left-hand corner. In the western region, we have myself and Ron Lalanek. Then in the central region, we have John Napolitano and Fran Kane. And actually, Tom Higgins should be listed with the east. Along in the east, we have Steve Maybloom and Gene Hickok. And then for any CHP projects, we do have John Rathbun. Also on our team, though, is our screening team, which you may have dealt with early on in the process, Carlos Puentes and Shashank Gauri. John Rathbun also helps out on that. So you may see those names early on in the process. That concludes our presentation today. Thank you very much for attending. We can now open up to questions. And remember that this session was recorded and it will be posted on YouTube, so you can refer to it later. Carrie, I don't know if the questions come into you or how that works.
Yes, so far I have one question, but feel free to start entering any questions you may have. I'll read off this question. The first one is, will we be providing the slide? And the answer to that is yes. Once we post the recording on YouTube, in the first comment is going to be a copy of a PDF, which is going to be this presentation. So look for that starting Friday. Okay, the next question that we have is, the list of action items in a CSER in the form of an Excel table is great. Can you please add the date of the drawing revision that was being reviewed? Just because it's not clear a lot of times which drawing revision was reviewed on your end.
So I can speak to that. So in addition to the drawing revision submitted, to add the date column, I think we can process that. So I'll take that away and talk to the engineers about adding that date. I would hope, though, that a revision would be indicative of a change in the drawing. So if the date of the drawing changed, then the revision would change. So we should only have one revision with one specific date. But we should be able to accommodate the date changes.
Great. Okay, next question. Are example drawings, including the AC/DC elemental drawing, available? Tim, are we going to be making those available anyplace other than the presentation?
Typically, we don't. You know, when we get into a project like that, if we have to, we can give them out for each individual project if necessary. But we don't have no place published where we have these typical drawings.
There are some examples within the ESBs that will give you some higher level, real simplistic formats of some of those types of drawings. If someone has a specific question on a project to what to illustrate, on a case-by-case, we most likely, if you were to ask, we could find something to help guide you through the process. So I guess the short answer is, if you have a question on what needs to be shown, feel free to ask. We're out here to make sure that your jobs are successful. We want to make sure the equipment and the infrastructure is in place that we require for safety and reliability of our personnel and our customers and our systems. So as long as we're working together, we'd be glad to help out with anyone who needs assistance with that kind of direction.
Great. I don't have any other questions at this time, so I will do the wrap-up. If anything else comes in, we'll interrupt and answer those. But thank you all so much for attending today. We really appreciate you taking the time to be with us to learn this really important information. Once again, this will be on YouTube as of Friday. Just keyword search National Grid Distributed Generation. Also, we will have the presentation available in a PDF form in the comments there, so you'll be able to take a look at that. All of the contact information of who you can call for your engineer or your project manager, please feel free to use that. And since we don't have any other questions at this point, we're ready to wrap up. Thank you again. Bye-bye.
Thanks, everyone. Take care.